This question is about an inclined plane where we have a rough surface. So we have a coefficient of friction, we have a rope pulling a block up the inclined plane. We know the mass of the block, we know the coefficient of friction, and we're asked to find the tension in the rope. So the key to answering this kind of question is to realize whether you're using Newton's first or second laws. So in the y direction, clearly there is no acceleration, so we're using Newton's first law. So Newton's first law in the y direction. That means perpendicular to the plane. Whereas in the x direction, that means along the plane, clearly there is an acceleration, so it's not balanced forces. So we're going to be using Newton's second law in the x direction. And that's key, really, because it means in the y direction we can say that the summation of the forces is equal to 0, whereas in the x direction the summation of the forces is equal to the mass times the acceleration. So that's your starting point, realizing whether you're using Newton's first law because it's balanced and there's no acceleration, there's no movement, or whether you're using Newton's second law. Now it's just a case of resolving the vectors and writing the forces in the right order. So in the y direction, we only have two forces. We have the normal reaction force and we have a component of the weight. So this component of the weight, I'll draw it here in yellow. So this component of the weight, Wy, is just the weight times cosine 20. Okay, so I'll write that out. That's equal to 3g cosine 20. And the sum of these two forces, that's r and 3g cosine 20, should equal to 0 because the object isn't moving in the y direction. There's no acceleration, there's no movement. It's in contact with the plane. So we can say r minus, because it's in the opposite direction, 3g cosine 20 equals 0. So r equals 3g cosine 20. So there we have the value of r. And that's really helpful because it'll help us to find the value of friction. And just putting that in your calculator gives you 27.66. So that's the value for r, which is the normal reaction force. Now let's look in the x direction, where we're going to be applying Newton's second law. How many forces do we have? From the diagram, it looks like we have only two. But we know that the weight, if you resolve it, there is also going to be a component of the weight that's in the x direction. So let's call that Wx. And Wx is just W times sine of the angle. So now the sum of these three forces, tension, Wx, and the friction, will equal to Ma. And just to make the friction really clear, I'm going to draw it here in pink, and that's my friction. We'll call it F. So if I start by saying, because it's accelerating up the incline, this T is going to be positive, and these two forces will be treated as negative. So T minus Wx minus the friction equals ma. What we're trying to find is the tension. So all of these we should already know. So T minus mg, or 3g sine 20 minus, the friction is simply the coefficient of friction multiplied by r. And that's equal to 3 times a, so that's 3 times 0.4. And the coefficient of friction is given in the question, 0.4. R, we just found that from the y direction. So really we can just rearrange to find t. We can say t equals 1.2 minus 0.4 plus 0.4 times 27.66 plus whatever that is. So 3 times 9.81 times sine 20 is 10.07. That gives me a tension force of 22.33. So that would be the final answer to this question, asking for the tension. So the key is to decide whether you're using Newton's first or second laws, then to resolve the weight into a horizontal and vertical component, and then just to add the forces up, making sure that you use the right signs. So when forces are in opposite directions, they have to have opposite signs. And usually you would find the normal reaction force from the y direction and then insert that into your friction force in the x direction.